Welcome to the course Business Analytics and Data Mining Modeling using R. So in the previous lecture we were discussing Neobase and specifically we looked at the formula for Neobase. So specifically we looked at the Neobase formula. We also looked at the steps for the same when we have a class of interest. When we don't have a particular class of interest, the general or typical scenario that we have also discussed in the previous sessions, right? So so these are some of the steps that we have discussed in the previous. So now what we are going to do in this particular lecture, we are going to do a small exercise to understand Neobase and the different and the various steps for Neobase modeling, computations and other things through an exercise. So we'll do an exercise using Excel and then followed by an exercise in R. So in the previous session we had gone through one example related to complete or exact base. So you can also see that classification matrix here as well, where we had computed the probabilities, right, fraudulent, given prior legal. So here this particular example was where we have just one predictor, and we had computed the probabilities of belonging to that fraudulent class and truthful class given that predictor's information, and based on that using most probable class method and cutoff probability method with cutoff point 2, also we had seen what would be the assigned class. Now the same thing can be extended especially using the Neobase calculation. If we have two predictors, so let's go through an example where we have two predictors. So first one in this case is prior legal trouble, as was in the previous case as well, and the second one being the company size. Now the status of those financial reports, whether they were found to be truthful or fraudulent, so that is also given here. So this is our data. So this is a small data set that we have. This is the highlighted section here. So as you can see, for observations, whether they had prior legal trouble or not, yes or no has been indicated appropriately. And for the company size, as you can see, whether the company size is small or large, that has been specified for every observation here. And then the status of these records, these observations, the specifically financial reports, whether they have been found to be truthful or fraudulent, so that is also specified. Now if we were to follow complete or exact base modeling, so in that case how do we go about different calculations and computations? So let's see. So let's say we have to compute this probability of a particular particular financial reports being fraudulent given the prior legal trouble and the company size, right? So in this case because we have just two predictors, two categorical predictors, and both these predictors are having two classes. So prior legal trouble, we have just two classes, either yes or no. For the company size also we have just two classes, either small firm or large firm. So given this two classes each for these two predictors, we'll have four scenarios. So we'll have we'll have these scenarios for four of these scenarios, for example. And specifically if we are interested in only identifying the fraudulent classes, so for the fraudulent we have these four scenarios when the prior legal trouble is yes and the company size is small. The second one, when the prior legal trouble is yes and the company size is large. Third one, when the prior legal trouble is no and the company size is small. The fourth one, when the prior legal trouble is no and the company size is large. So as you can see, since we are interested in calculating the probabilities mainly for the fraudulent class, so this is how we can do it. So these are the details. So these details I have further written down in three separate columns, mainly to be able to use Excel functions and to perform computations. So you can see the status, and then prior legal, and then the company size for all these all four probabilities value that we want to compute. So I have specified here. Now to compute the exact base probability, this is how we can do it. You can see first you can see I am using this Countif function in Excel. So what it does, we can look at the details if you are interested. So you can see, let it load Countif function. So this is what we are going to use to perform our computations here. So function applies criteria to cells across multiple ranges and counts the number of times all criteria are met. So a particular criteria which is specified, that is applied across the range, and then the count is done. So you have to specify criteria range 1 and then the criteria. So you can therefore in this function you can specify multiple ranges and the associated criteria for all those ranges, which is exactly what we want. So essentially the reason being, because we want to compute this probability, you can see that the first one here, you can see this one, prior legal trouble, and then followed by the L2 value, that is yes. So you can see here in this particular color. So color coding is also quite visible here. So in this first criteria would actually help us identify all the yes observations which we want, all the firms which had prior legal trouble. So we want to identify all those firms. So there are 1, 2, 3 and 4 such firms here. So first criteria and the first range and the associated criteria, that is yes, will identify or select or filter those firms. Then if we look at the second one, right, second one is for the company size. So the criteria is small here. So in this particular column we want to find out all the firms which are having a small size. So now in this together these then the further next criteria, as you can see, is that is whether the firm, whether the status is fraudulent or truthful. So you can see the next range is that shown here in the green, and within this we would like to apply this criteria that the firm is fraudulent. So these 4 observations, they would be identified. Now Countif function will apply all these criterias, right, and then the number would be counted of those observations which satisfy all these criteria. So therefore firm has to be yes, firm has to that prior legal trouble as yes, company size as small, and status as fraudulent. So only those observations would be counted here. Then followed by the next one, as you can see here, the denominator part. So numerator part we have understood. So all the counts of the firms which had prior legal trouble as yes and company size as small within the fraudulent class, so that would be counted in the numerator, and in the denominator we would have the again 2 criterias. So first one is that the company had prior legal trouble as yes, and then followed by whether the company size was small. So that is the denominator. So out of all such firms, so out of all such firms which had the predictor information as the prior legal trouble being yes and company size being small, we would like to find out the number of firms which had status as fraudulent. So once we execute this particular Excel formula, then we get the number which is 0.5 in this case. If you want to check whether our formula worked correctly or not, you can do so by understanding from this table. Let's look at the yes and small firms. So yes and small here 1, and then we have 2. So there are just 2 cases, one yes and small status being truthful, and 2 cases yes and small status being fraudulent. Now out of this out of these two cases for yes and small, right, out of these 2 cases based on these 2 predictors information, only one of them is fraudulent status, only one of them is having status of fraudulent. So therefore the probability is going to be 1 divided by 2, which is 0.5. So our formula is computing this particular exact calculation correctly, right. Now in the same fashion again we can compute the exact base probability for the second scenario, that is probability for a particular firm filing submitting fraudulent financial reports, given that they had a prior legal trouble as yes, and then company size also large. So the same fashion, Countif function, using the Countif function available in Excel, we can compute this particular value as well. So because this is a small data set again, so we can find out from this particular data set itself what is the probability. So yes and large, if you look at the number of observations matching these records, as we discussed in the complete or exact case, you have to find the exact matching records, so 1 and 2, right. So out of these 2, both are fraudulent, so therefore 2 out of 2, so therefore the probability is going to be 1. The same thing has been computed using the Excel formula as well, right. So the formula also, the Countifs, as you can see, criteria ranges and criteria, so that has been specified. So for all 3 cells, whether the firm is fraudulent or fraudulent reporting, or and the prior legal yes, and this company size as large. So these 3 criteria in the numerator, and in the denominator only the 2 criteria, that is the predictors information yes and large. So that would give us the correct exact probability for this particular case. Similarly for the next case, when we want to compute the probability of a firm being fraudulent given the predictor information of prior legal trouble being no, and company size being small. So in the same fashion also we can compute. As you can see, no and is small, 1, 2, there are 1, 2 and 3, there are 3 exact matches in this particular small data set that we have for this situation, no and small, but all three of them are actually truthful. So therefore none of them are fraudulent, so the probability is going to be 0 divided by 3, therefore 0, right. Similarly for the last scenario, no and large, again we can look for the exact matches, no and large 1, low and large 2, right, and low and large 3. So in this case, so first two cases of exact matches, no and large, they were truthful, the last one was fraudulent. So therefore the exact probability is going to be 1 out of 3, that is 1 divided by 3.33. Same thing we have computed using Excel formulation as well, right. So in this fashion we can compute the complete or exact, we can do the complete or exact base calculation, and based on that we can perform further steps. Now if we were to perform the same steps using a new base calculation, right? So how we will do this? So the same 4 scenarios, right? We are interested in identifying fraudulent cases because for a accounting firm, as we talked about, they would be interested in identifying the fraudulent reports first, because then they can decide about serious auditing or serious scrutiny of those reports, right? So these 4 scenarios, again the same scenarios as for the exact base calculation. The same fashion we have written this particular details in 3 separate columns, whether for the calculation of the probability. So in this case, you can see how we are trying to compute the new base, probability. So in this case, we have generated first these conditional probabilities. So first let us have a look at the these conditional probability that have been computed. First look at the proportion of records which belong to each of these classes. So the proportion of records which belong to the fraudulent class are these many. Let's look at the formula here. So you can see the last column is status out of these records, which is in the denominator, and in the numerator. Then we have the criteria, which is specified as false. So out of these, how many are actually, out of these records, how many are actually fraudulent as status? So we will get the appropriate number, which is 0.4. Same thing you can compare by just looking at this particular data set, because this is quite small. So you can see just 4 out of these 10 observations, they are fraudulent. So therefore 4 is the probability. Similarly, for truthful class, the same fashion we can compute. So out of this column, we can see 6 of the observations, they satisfy this criteria. So therefore Countif, this particular formula that we have written over there, is going to return the value as 0.6. Now let's have a look at the other conditional probabilities that we have computed. So this is so we have 2 predictors, so therefore and then 2 classes in the outcome variable. So for first this fraudulent class, and these are the 4 values for 4 values with respect to the predictor, this prior legal. So you can see in the numerator, you can see we are trying to identify, find out the value wherein as you can see, yes, where the prior legal trouble is yes, right? So that is the first criteria. That is one criteria, prior legal trouble, yes. And also the record is supposed to be fraudulent. So these 2 criteria, they are in the numerator, so those counts are to be done. And this particular count is then divided by the denominator, which is nothing but the number of records which are fraudulent out of the total records. So using this, we can find out this particular probability of a record, record being having a prior legal trouble, given that it belongs to the fraudulent class. The same thing we can do here. In this case, this is for the second predictor, that is company size. So again we can have a look at the formula. So here also for this here also you can see that for the small, so we have to look at this, that for given that this predictor information, that for this particular form, this is company size is small, right? For this out of the fraudulent cases that we have, what is the probability for from belonging to that. So this is comes out to be 0.25. So after this we can compute the we can perform the same computations for 3 other scenarios. So you can see, so these values have been computed. Similarly, the same thing has been applied here in the truthful class. So here also the same thing is being applied, as you can look at the Excel formula as well. That for the same for the first predictor, that is prior legal double, and the first value being yes. Now we are trying to count the numbers wherein this particular is predictor value is yes, and then the class is truthful out of all the classes which are out of all the records which are truthful. So this value comes out to be 0.17. So the same thing we have done for other 3 scenarios. Similarly, for the next predictor, that is the company size, also the same type of computations have been done. Now once these values have been computed, right, so if we look at the naive Bayes formula that we have gone through, if you look at the naive Bayes formula here, you can see that these are the probability values that we are trying to compute here. Px1 given Ci, Px2 given Ci, right, and the proportion PCI, this we have already computed, and Px1 Ci and Px2 Ci, these values we have already computed, right. So these 2 values. So for each class of the class F, so these are the values for predictor 1, predictor 2, for class truthful, for predictor 1 and the predictor 2, and then for all the scenarios. So we have computed these values, right. So we have been able to compute these values. Now once these values have been computed, we can compute the overall formula for naive Bayes. So this is in this particular cell, as you can see. As you can see from here, this is these 3 cells. You can see these 3 cells. 3 cells are in the numerator 08, that is this one, and then multiplied by P8, this particular cell, and then multiplied by P7, this particular cell. So we are trying to compute the probability, right, of this particular part, and then divided by the total. So that will give us this value as 0.53. So to compute the actual probability, as we talked about, the first you have to compute the numerator, and then you have to divide by the same expression values for all the classes. So this is what we have done. Similarly, for the next scenario as well, here also we look at the formula. First, for the fraudulent class, which we are interested in, because we want to compute the probability of belonging to a fraudulent class, you can see. So these values are 09 and then multiplied by P9, and then multiplied by the P7 value. So these 3 values, and in the denominator we will have this one value plus the other one value which belongs to the truthful class, and we'll get the actual probability as per the naive Bayes formula. Similarly for third scenario, and similarly for the fourth scenario. So exactly following the naive Bayes formula, this one for the naive Bayes calculation, and as we have discussed this one for the exact Bayes calculation. Now once these computations have been done, you can do a comparison of these 4 scenarios. So we look at the complete or exact Bayes values. You can find out that this was 0.5 probability of a particular report belonging to the fraudulent class, and given the prior information yes and small, and the same thing you can see the value is 0.5 and here it is 0.53. The second one, the fraudulent class, prior legal period yes and company size large, it is 1 for in exact base calculation, 0.87 here. In this case, the third scenario, prior legal period no and small firm, this is the 0.07 in the exact base, this was 0.0. Here it is 0.31, in the exact base it is 0.33. So if we look at the probability values, the actual probability value that we get from naive Bayes calculation, they are quite close to exact Bayes calculation. However, we don't have to deal with one overwhelming problem that we face in exact Bayes calculation, is that we have to find the exact matches, records exactly matching. So that we don't have to do, because we use the entire data set in naive Bayes calculation. So you can see close numbers in both exact Bayes and naive Bayes calculation, and based on these probabilities value, then we can decide on whether to classify as truthful or fraudulent. So these probabilities value, if we are not interested, if we are not in a rare class scenario, then we don't have a special class of interest, then in that case we have to compute these values for the truthful class as well for all scenarios, and then we can compare. And as we had done here in exact Bayes, this particular example, for the fraudulent as well as truthful, we had computed these two values, and most probable class method can be applied to find out whether the observation is going to be assigned as truthful class or fraudulent class. Cutoff probability, if we follow the same thing, 0.2, right, then accordingly in this case also, for example, as per naive Bayes calculation or even for exact Bayes calculation, we follow the cutoff rule, right. Using these probability, we can assign a new observation to the appropriate class. For example, first, second and fourth scenario, they would be assigned as to belong to the fraudulent class, and the last one, the third one, would be assigned to belong to the truthful class. So with this, let's do a small exercise in R. So what we will do is let's get familiar with the data set that we have here. So the data set that we have here is this one. So this is the data set that we are going to import into our environment, and then we will be doing an exercise in R for applying naive Bayes modeling. So let's look at the variables that we have. So these are the variables that we have. First one is flight carriers. So this particular data set is about flights. Their carrier, the date, then source, and here then we have scheduled time of departure, actual time of departure, then we have scheduled time of arrival, then actual time of arrival, then we have destination, and then we have day of week. So one representing here Sunday and two representing here in two representing here as Monday. So we have just 2 days of information, whether the day was Monday or Sunday or Monday. Then the flight status, whether the flight was delayed or on time. So this is based on whether the actual time of departure, whether that was less than or same as the scheduled time of departure. If it was less than or same as the scheduled time of departure, then it is on time. If it is more than that, then it is delayed. So the main problem is the classification task, and the predictors, as you can see from the data set itself, the predictors that we are going to use in the modeling are going to be the categorical predictors, and in this particular case, the main task being the classification task, we are trying to predict the status of a flight, whether it is going to be, depending on the predictors information, whether the flight is going to arrive on time or it is going to be delayed. So so we'll stop here in this particular lecture, and we'll continue this particular exercise in the next one. Thank you.